All right, y'all. We're going to start matching these functions. F of x. Who thinks they got what letter we should go to for f of x? All right, Charlie.
C.
See, let's take a look. To get the output, multiply the input by 3. So 3x, okay? Then subtract 7 from the result. Do I need parentheses right here? No, because the order of operation is going to require the multiplication to happen first. Okay, g of x. Who's got the match? Wait.
B.
Thinking B. Let's take a look. To get the output, subtract 7 from the input. So that's a x minus 7. Then multiply by 3. Ooh. So do you need the parentheses on that one, right? Otherwise, you would not subtract first. Cool. H of x. We're down to a 50-50 chance here. What do you think, Sebastian? Let's take a look. To get the output, divide by 3 first. Yeah, we have to do x divided by 3 first. If you go here, x minus 7 is grouping, right? So even if it doesn't have parentheses, that is still a grouping situation. That's why I prefer if we're going to use something, GEMS over PDS, or GEMS over PEMDAS, okay? Because grouping, this is grouping. So, Elizabeth, you want to give that last one a shot? I saw you raising that hand. Oh, hey! And so subtract 7 first does happen regardless of parentheses. Be cautious. On calculators, students often will type in something for like let's say the input's 2. They'll write 2 minus 7 times 3 all in a row. Guess what your calculator will do first then? If you just type in 2 minus 7 times 3 all in one row.
Multiply.
It'll multiply first because the order of operation. So if you're going to type this into your calculator, you have 2 options. Option 1, type it in parentheses, x minus 7. Or what I often find myself doing, even though it maybe isn't more efficient, I would type in like 2 minus 7 equals and then divide by 3 equals. Just note, the 2 minus 7 has to happen first. And your calculator is not smart enough to know that that's what you intend unless you tell it that. You guys, I can write it. If you were to write x minus 7 times 3 in your calculator, or let's say x is 2, just to give us a number, it's going to do that first. Okay, because your calculator doesn't know that you're trying to subtract first there. So just be cautious of that. That's like a mistake I'll see sometimes on quizzes. All right, so next up for number 2, which function has an input of 6 and an output of negative 3? Input of 6, output of negative 3. You guys already did this, right? Input of 6, output of negative 3. Which one, F, G, H, or K? Emily. Let's G. So let's test it out. So you're saying G of 6 is 3 times 6 minus 7. Okay, so G of 6 then equals 3 times negative 1, which is input of 6, output of negative 3. Thank you, Emily. That works in G. So which one has the greatest when the input is 0? Let's check it out. F of 0 equals 3 times 0 minus 7. So F of 0 equals negative 7, okay? So currently the greatest. We'll see. G of 0 equals 3 times 0 minus 7. So G of 0 is negative 21. Oh, F of 0 is still the biggest. You guys following? H of 0 is 0 divided by 3 minus 7. Negative 7. Okay, we're tied with F. Let's see K of 0. 0 minus 7 over 3. K of 0 is negative 7/3. Winner, winner. Chicken dinner. Negative 2 1/3 is the largest, even though it's negative. So again, it's that whole input-output. Yesterday we looked at graphs, right? Like if 2 goes in, 5 comes out. And remember on that cool down, if 3 comes out, we figured out what went in, right? So there's ins and outs. Today we're learning the ins and outs of it, okay? This is where you're going to use your note sheet I handed out. We're going to look at developing functions for rules now. So we're going to start with perimeter of a square. What's cool about a square? It has 4 sides. Okay, that's cool. I can get behind that. And what do we know is true about the 4 sides of a square? They're all the same length. So I'm just going to say S for side, right? They're all the same side length. It's your job, please, to fill out the area in the table Complete the table. Write a rule for your function. That's going to happen down here. I'll highlight it. You're going to write a rule for your function. You're going to say what the input of 2 means in our context and graph it. Eyes up here, mouse closed, please. So help me out. Get these areas of these squares. 1 squared.
1.
2. Oh, I'm writing with the highlighter. 2 squared. 4 squared.
16.
The correct answer was a fun playground game.
36.
Nothing. 4 squared. 6 squared.
32.
S squared.
A equals
Okay. So we're going to write a function. And remember, this A we're writing is not a variable. It is only a label. So this is saying function A. It's just the name of our function. It's like John, okay? Function John. This is function A. That's John. Okay? And what's going into our function? Side length. I know side length is going into my function because it's right here as the x value. I also know because side length changes the area. It's an independent variable. And what do I do with my side length to get my area? We square it. So there's my rule. This function, forever, if I know any side length, will give me the area of a square. So someone hit me with the side length. 8. 8 squared. 64. 8 goes in, 64 comes out. Hit me with another one.
10.
Ooh, 10. 100. 12. 144. 13.275. Don't have it. But we could calculate that sucker. We could.
43.
So, again, we've been working on function notation. When we read this, it says function A, which is this. A side length goes in, an area comes out, the side squared. Callie.
This is kind of unrelated to the lesson, but like if we...
So, A of 2. So I'm going to check out A of 2. So 2 comes in, what comes out? 4. And what this notation says in context, which we've been practicing the last couple days, the function of this situation, when I have side length 2, my area is 4. Okay? Let's graph it. 0, 1 is 2, 2 is 4, 3 is 9, 4 is 16, ooh, 5 is 25, 6 is 36, 7 is 40. I'm just making this. And is this going to be a continuous or a discrete graph?
Continue. No, discrete.
Ooh, this is good.
Discrete. Or continuous because you can have points.
Could we have decimals and fractions for our side lengths? Yeah. So it's gonna. I wouldn't use them as reference points unless I had to, but yeah, this is going to be continuous.
That's what I did.
Nah. Ooh, Charlie, I like that. But okay, let's do the Charlie mode. Boom. It looks like it's going to go infinitely up, but actually this is, you would use like terminology like approaches infinity, which is kind of fun to think about. This is an exponential function. We'll be learning more about these in the next unit. Okay, now we're talking about a roll of regular paper. Imagine 3 feet wide toilet paper. I'm doing it right now. Yep, that'd be cool. But it can cut out any length from this 3-foot roll. So I'm actually imagining now, I'm not imagining toilet paper. You know that paper that the teachers have in the teacher's lounge on like the big roll?
Yeah.
That's probably about 3 feet-ish. But let's say even if it isn't, that's what I imagine. It can be cut to any length, but it has to be 3 feet wide. Okay? You're going to roll through the questions associated with this paper situation. So again, it's 3 feet wide coming off the roll, but you can cut it to any length, right? Put it at the end of the hall. Maybe I just walk all the way down here. We go a whole hallway. That'd be fun. Maybe wasteful, but fun. Okay? So you're going to roll through these questions with your partner. I think this should take about 6 minutes. Okay? Let's get after it. Okay. So I don't care what we do first. Let's vote. You want to roll through 2A first or do the table first? Raise your hand for 2A.
Table.
Raise your hand for table. I kind of like the table first because I think it might help me with 2A. Okay. So if I have a side length of 1 foot, I think it's a really nice visual to just draw a picture. So I know I'm getting 3 and 3 and 1 and 1. So we have how much? 8. And if I had 2 and 2 and 1 and 1, I'd have what? 6. And if I had...
What?
No, 3's the
Watch.
one that stays the same.
Oh yeah, I messed that up. Here's 8. These changed to 2. I got 10. These changed to 6.3.
18.6.
I got 18.6. I changed these to 11.
28.
What do I got? 28. So what's always happening to the length? I'm always starting with how much no matter what. I'm always starting with 6. And then what's happening with my other lengths?
No, not e squared. No.
Not squared, times 2.
Uh-oh.
So here's my rule. Next, we're going to write a function. 2 lengths, input L.
Why did I was in E?
That's italics.
It's like a really fancy.
That's an italics L. But if you wrote an E, if you had an E, you have the right idea.
It's gonna be like a little bit.
Okay. So it's called P. It also says side length is feet in L. But the function P, what's going into our function over and over?
11.
6. P. L.
L.
Let's go.
The length.
First try.
Okay.
Length's going in. And when length comes in, what comes out? Perimeter.
Why?
6 plus 2 L.
It's kind of. Yeah, it is one. So here's our rule. Let's test it out. Let's test it out. 2 goes in. 6 plus 2 times 2, is it 10? Yes. 11 goes in. 6 plus 2 times 11, is that 28? Yeah. Our rule works. It rules. So what does P of 11 represent?
28.
No, what does it represent?
Side length paper with the side length of 11.
Side length of 11 goes in. What comes out? The perimeter is 28 when I have a side length of 11. So remember we were writing those sentences before? Okay, what is its value? Well, it means when I have side length 11, my perimeter is 28. Okay, let's get sketchy. 1/8. 210. 6.3, 18.6. That's a fun one. 1128. Doesn't fit. What's our y-intercept going to be?
6.
It's going to be 6. How'd you know that, Harper?
Because I did the 2 sides plus each other.
Also,
It's
the b value in a linear function. Yeah. What's the slope? What's the slope, guys? 2. It's the m value in our linear function. Awesome. It's a linear function, right? 2x mx plus b. Y equals mx plus b. Tight. All right, we're going to do a lesson summary next. You have this. Mouths closed. So 0 apples, how much that going to cost us? $0, okay? 1 apple, or 1 pound, I should say.
$1.
$1.49. 2 pounds?
2.96.
2.98.
$2.98. 3?
Oh boy, Brody, you gave me the wrong number.
4.47.
3 is what?
4.47.
So n is going to be?
1.49 N.
All right, so it doesn't say this down here. It says it up here. Let's write the rule for the function of n. Function c. So I'm going to c of n, which means if I put in the pounds of apples, the price comes out, right? So how do I get the price? $1.49 n. $1.49 per pound. So when I read this, n is the pounds of apples independent. The price is the dependent coming out. But our rule is going to go into there, the thing we do over and over. So here is our table. It's linear, right? What's the y-intercept? It's right here.
Oh,
0. And what's the slope?
1.49.
Yeah, $1.49 per pound. Okay. So at $7, or not $7.25, what's 7.25 there? Money or pounds? So I can figure out how much that costs by inputting that into my function. And how much would 7.25 pounds cost? $10.80. All right. Apples aren't that expensive if you think about it. $1.50 a pound? Like cheap burger costs like $4 a pound. So you want to eat healthy, eat some apples. $1.50, that'd be like a snack pack of chips or a whole apple. What's going to be better, right?